Hello everyone, myself Ankita, faculty of Department of IT, Akgec. In the previous video, I have discussed about various types of uninformed search techniques, and in this video, I will be discussing informed search techniques of Unit 2 of course KCS 071, that is Artificial Intelligence. Now, uninformed search techniques are the search techniques in which we are searching for the goal node in the search space in a random manner. So we don't have any information of the problem domain. We just know about the goal node, and we were searching in a brute force method the goal node, right? But in informed search techniques, it is a smart search methods which uses special knowledge or hints to find out the solutions more efficiently. So here we are using some hints, some intuition to find out the goal node. Now, informed search algorithms contains an array of knowledge such as how far we are from the goal, path, cost, etc. So here we have some extra information. Here we have some intuitive value which tell us that how goal node is closer to us. So it is we can also say informed search techniques are also guided search techniques where we are being guided to the goals. Now, this knowledge, the main problem of your uninformed search techniques was as the search space increases, the complexity of finding the goal increases exponentially. So it becomes very difficult to find the goal node if the search space is very huge. So in such cases, we are using your informed search techniques where we are using some special knowledge or hints or some intuitive value to understand how far is my goal node from the current node. So this knowledge helps the agent to explore less to the search space and find more efficiently the goal node. Now, the informed search algorithm is more useful for large search space, and it uses the idea of heuristic. So here whatever I'm talking about hints or extra information, it is called as heuristic value. Now, to explain better the importance of your informed search, let us take an example. Suppose I am at location A and I have to reach a location B, right? Now, I don't know the path to B and I don't know how much time will it take me from A to reach to B. Now, if I'm using your uninformed search techniques, I have to consider all the routes that are emerging from A so that I can reach to B, right? Now, if I am in a very big city, right, and I have to reach B, so it will be very difficult for me to find out which path I should take so that I reach B, right? So uninformed search strategies will fail in such a case. So in that, if I use informed search strategy, I will be asking a person nearby who is knowing about the area, and I will ask him to suggest me that please tell me which path I should take from A so that I can reach B in a convenient time. So that person will tell me, okay, you can take this route and you will be able to reach to B. So if I'm using your heuristic or some intuitive hints, so I will be following this route and I will be definitely reaching to B. So that is your informed search technique. So informed search technique will always help you to find out the solution faster. Now, when we are talking about heuristic search technique, the important thing is your heuristic function. Now, heuristic function will tell you the value, and it is just a value that will help you reach the goal faster. So it is a function which is used in the informed search, and it is find the most promising path. The heuristic method, however, might not always give the best solution, but it is guaranteed to find a good solution. So your uninformed search techniques always guarantee you the best solution, the most optimal solution. But your heuristic search technique does not guarantee you. Why? Because in the previous example that I have mentioned, you have asked a person, right? You have asked a person, please tell me which path I should choose. Now, if the person is well confident, is knowing about the domain or the map, he will give me the correct information. But what if the person is not aware? He just tell me his random guess that you can choose this B. So in such a case, we would never be able to reach the goal. So it all depends upon the heuristic. So if the heuristic value is well chosen, we will be able to reach the goal node. But if it is not the heuristic value is not chosen wisely, so we would not get the solution. So we can always say heuristic method will always give you a good solution, but it does not guarantee you the best solution. Now, the heuristic function always estimate how the close a state is to the goal. So we are depicted by this h of n. It is the heuristic value is depicted by h of n. This is your heuristic value, and h star n is the actual value. Suppose I am at location A, and this is my destination node, and I have 3 paths emerging from here, right? Now each path will tell me how much time will it take to reach this goal. So it is an approximate value. So if I'm asking the person, he can say you can reach this point if following this route in around 10 minutes, right? If you're following this route, you will reach in 5 minutes. And if you are reaching this node, you will reach in around, say, 130 minutes. So these are what? This is your heuristic value. Now, what is the actual value? So if I am choosing about this, so here h of n is your 5. And how much time I am actually taking? So suppose I am taking around 10 minutes. Right? So this is my h star n. So this is my actual time that I have taken to reach the goal node, and this was the time that was been told to me that at 5 minutes you will be reaching to the goal node. So it is a rule that whatever heuristic value that we have chosen should always be less than the actual value, right? So this is when we are calling it as admissible heuristics. So we will discussing in detail later. Now, informed search techniques, we have majorly 2 algorithms, that is best first search algorithm and your A star algorithm. Now, what is best first search algorithm? It is a greedy search method. Now, you have already studied about greedy search in your previous classes. A greedy search is where we are greedily selecting a path that appears best at the moment. So, whatever path, I can have multiple paths at the moment, whatever path that is looking to me that it will give it will help me to reach the goal faster, I will choose that. So in the best first algorithm, we expand the node which is closest to the goal node, and the closest cost is estimated by the heuristic function. Now suppose I am at this position A and this is my goal node, right? Now these are 3 nodes. So suppose this is called 1 node, 2 node and 3 node. So in your best first search algorithm, these 3 nodes will have a heuristic function attached to it. For example, the node 1 will tell A that if you will come to me, I will make you reach the goal with the cost of 10. 2 is telling that I will be reaching goal in cost 12. And suppose 3 is claiming that he will let A reach the goal through itself with a cost of 5. So this is the value of this. So if A is going to node 1, he can reach the goal with the cost of 10. Here h of n will be 10, right? Now if A moves to node 2, the 2 will help to reach the goal node with the cost of 12. So here h of n will be 12. Now if A is choosing 3, he will let the A reach the goal node with the cost of 5. So this is what called as h of n, and how we are deciding the path in the best first algorithm. Now what is the algorithm? In best first algorithm, we are using 2 lists. One is your open list and other is your closed list. So whatever nodes that we have to explore, we keep in the open list, and whatever nodes that we have already explored, we keep that in the closed list. So we start with placing the starting node in the open list. Now if the open list is empty, we have to stop and return failure. So if all the nodes have been explored, there is no node left, so we will have to return failure. Now if there is some node, we will remove that node from the open list and we will place that in the closed list. So how we are going to remove nodes from the open list? We will remove only that node whose heuristic value will be lowest, right? Here heuristic value will be lowest, and therefore we are using here priority queue. So here we will be using a priority queue because in the open list we have many nodes, and for each node we'll have an h of n value, that is suppose 3 and 2. So we will be removing b first. Why? Because it has the smaller heuristic function value. So we will be removing b. Next, after removing b node, we will be expanding that node. What do you mean by expanding that node? Expanding that node means we are generating the successors of that node. So when we are generating successor of that node, we will now check whether we have reached the goal node or not. So whatever successors we have, suppose we have successors C and D. So we will be seeing whether C and D are goal node or not. So if it is goal node, we will be telling out that it is returning success. Otherwise, what we will do, we will again repeat the process of finding out and what is the heuristic value of D. Suppose this is 5 and this is suppose D have 1. So now our open list will have 3 participants, 3 nodes. So we will choose again D, the lowest value heuristic. So similarly, this process will be repeated again and again till we get the goal node. If we cannot find the goal node, we will have to return the failure. Now let's understand this with the help of an example. Now this is my graph. Now these values, these are the nodes S, A, C. These are all nodes. This is your starting node and this is your goal node. Now, now these 3, 4, 1, 2, these all are the path cost. Means if I have to reach A from S, I will need a path cost of 3. For B, I have the path cost as 2, right? Now, what is this Hn? Hn are the values that are claimed by the nodes that will help the search procedure to reach the goal node. So, A is claiming that he will give you the path to goal with a cost of 12, right? B is claiming that it will help to reach the path to the goal with a cost 4, right? So, both the values of h of n, here h of n is 12 and here h of n is 4. So, in the open list, we will have A and B, right? A and B we will have, and in the closed, this is your open list and we have a closed list in which we have the node S because it has already been explored. Now, when we see the heuristic value, it is 12 and 4. So, which node we will choose? We will choose a smaller one. So, we will choose B. So, we have chosen B. We will put that in closed loop and we will start exploring B. Now, from B, I could find 2 nodes, E and F. Now, E is claiming that it will help me reach the goal node with a cost of 8, whereas F is claiming that it will help me to reach the goal node with a cost of 2, right? So, we are keeping this in E and F. Okay. So, E is telling with the cost 8 and F is telling 2 and A have the cost of 12, right? Now, with the priority queue, which will be removed? We will be removing F. So, we have removed F and we have put that in a closed loop. Now, F have the path I and G. So, we will be using I and J, right? So, we can see G have the goal heuristic value of 0. So, we will be reaching goal node. So, we will be following this path to reach the goal node. So, that was your heuristic value. Okay. So, that was your best first search. We were trying to find out the goal node with the best first search algorithm. Now, what are the advantages of best first search algorithm? It can find out the solution without exploring much of the search space. Obviously, since we have a heuristic value with us, we will be searching less of the search space. Only the promising nodes which have good heuristic values, we will be exploring only those nodes. It uses less memory than other informed search strategies like A star. So, we will be studying A star later. So, it is better memory efficient than A star. Disadvantage, it is not complete. In some cases, it might get stuck into the infinite loops, obviously. So, it is not complete. It is not optimal also. It does not guarantee the shortest possible path will be found because this algorithm is highly dependent on the heuristic value. And since it is heavily depending on the accuracy of the heuristics, these are the problems that we can face, because if the heuristic values are not properly chosen, we can be misled to some wrong path, and obviously then we might get into some path which can never lead us to the solution. So therefore, this is the problem of your best first search algorithm. Now, if evaluating efficiency of best first search, it is not complete. Why? Because it cannot guarantee you the solution every time. It is not optimal, and the time complexity is worst case is order of b to the power m. This is the same as that of your best first search, breadth first search algorithm. In worst case, it will behave like this, and worst case is order space complexity of your best first search algorithm is worst case is order of b to the power m. So that was your best first search algorithm. Next is your A star search algorithm. Now, A star search is an informed search algorithm which evaluates a node based on the combination of the cost of the path from the starting node to that node and the estimated heuristic function. Now, this is a bit different. Now, suppose I am at a node A. I will be taking a similar example, and I have 3 nodes, 1, 1, 2, 3, and I have a goal node G, right? Now, in your best first search algorithm, we were only considering these values, right? The cost h of n. We were only considering these values, that whatever node we are going next, which that node is suggesting how much cost it will take for it to reach the goal node. So, but in your A star algorithm, it is also assuming the cost of how much cost I will take to reach start from from the starting node A to the 1. So, this is your G of n. So, here, so best first search algorithm, so each one of them will have your G of n. So, in your best first search algorithm, we were only focusing on this path, but in your A star search algorithm, we are focusing on both the parts. So, this is called as your evaluation function. Okay. So, this is your evaluation function, which is consisting of cost to reach node n from the start node, whereas cost to reach the node n from the goal node. So, that was your A star search algorithm. Now, it is a combining features of both UCS and greedy best first search algorithm. Uniform cost search algorithm we have discussed in your uninformed search strategy. So, it is a combination of your UCS, that is uniform cost search, and your greedy best first search. So, A star search algorithm find the shortest path through the search space using the heuristic function. This algorithm provides optimal result faster. So, A star algorithm is similar to USS because it is only using G of n plus H of n. So, your UCS or uniform cost search algorithm was based on only G of n. Your best first search algorithm was based on your H of n values, where your A star algorithm is based on both at G of n plus H of n. Okay. Now, again, the algorithm is similar to that of your best first search algorithm, and the difference is that when we are selecting the node from the priority queue, we are keeping into the consideration the value of evaluation function, that is G plus H, and rest algorithm is same as that of your best first search algorithm. Now, we'll try to understand with the help of an example. Now, this is your starting node A, okay, and we have to reach the goal node. Now, and the values that are written over the nodes, these are your heuristic values, whereas these are your path values. So, we remember the formula, f of n is equal to G of n plus H of n. So, whatever values that are written on the top are H of n values, and G of n are the path cost. So, basically, this G of n will tell you the path cost, that is from the starting node, how much cost it takes for me to reach from A to F, that is your path cost, whereas your H of n is from A, if I choose to go to F, F ensures me that it will reach the goal node with a cost of 6, right? So it is telling it is telling the algorithm that if you chose me, I will assure you that I will help you to reach the goal node with a cost of 6. So it is just assurance, it is not exact value. Please remember that. So from A, we have two neighbors, B and F. So we will be calculating the heuristic, the evaluation function values of both of these nodes. So it will be 6, this is your g of n value, and 8, that is your heuristic value. So it will come to be 14. Similarly, for f of f, we get the value 6 plus 3 is equal to 9. So which is less? Obviously f of f is less. So we will choose this node and we will start moving to f. Okay. Now from f, we have got two nodes, g and h. Now for g and h, I could say the value of f of g is 3 plus 1, 4, 4 plus 1, 5, that is 4 plus 5 is equal to 9, where of h is 7 plus 3, 10 plus 3, 13. So this is your g of n. G of n will be, g of h will be how much? 7 plus 3, that is 10 plus heuristic value is 3, that is your 13. So again, which is less? That is of your g. G is less. So again, the path will be, we will choosing G. Now, please keep in mind your J is your goal node over here, right? J is a goal node. Now, where we have come? We have come from this path. Okay, we are following this path. Now, from H node, there is only one node visible, that is I. So obviously, I will go to that node I. Okay, so my path is AFGI currently. Now from I could see there are three nodes, G, E and J. Now G we have already explored, and E will assure me from node E, step. So from I we have E, J and G. So H is, f of h is 12 and f of I is 10. So fj is least, so we will be choosing J, this part. So see, from when we have reached I, there are two neighbors, E and I. So I will be choosing I. Why? Because I has 0 cost and 3 plus 2, 5 plus 7 plus 10, that is 13. So it is giving me less, that is 12. So therefore, this is your smallest path. Okay. Now this is your required shortest path from A to J. Advantages is A star algorithm is best algorithm than other such algorithm. It is optimal and complete, and it can solve various complex problems. Disadvantage is that it does not always produce the shortest path, as it mostly based on the heuristics and approximation. The disadvantage of every heuristic based algorithm is that it is highly dependent on the heuristic. So if the heuristic values are not properly chosen, we won't be able to get the done. A star algorithm is complete, it is optimal, and the time complexity depends on the heuristic function, branching factor and the search space. Space complexity is also dependent on the priority queue size. Now this is important topic, condition of optimality. So as I have discussed earlier, the whatever value that we have predicted and whatever value is that is actual value, the value that we have predicted should always be less than the actual value. That is, we should never overestimate. So an admissible heuristic is one that never overestimate the cost to reach the goal, right? So we should never overestimate the goal. For example, if you are going to suppose a mall and you have to reach there in less time. So suppose you have 15 minutes. Suppose example, you are going for an interview and you have to reach there in 15 minutes. And you have, so what you will do? You will take an auto and you will tell the auto driver that yes, I have only 5 minutes, 10 minutes, please take me there faster. So in such a way, you have, what you are doing? You are being optimistic that will reach faster in such a case. So we should always be optimistic and we should never overestimate. The actual value should always be greater than whatever value that we have predicted. So we mostly uses the Euclidean distance or straight line distance to find out the distance between two nodes. So this is an admissible heuristic. Next is the condition of optimality. Now optimality says a heuristic h of n is consistent for every node n and every successive n dash by an action A. So if we have a node n, this is a goal node and this is your another node. So this value, a value of h of n for this path and the value of h of n for this path should, and the value that takes me to reach n dash from n is this. Okay. Now this value should always be smaller than the sum of these two values. This is an example of triangle inequality and it is called as consistent heuristic. So always remember, if the heuristic is consistent, it will also be admissible. So that was for all today. We have discussed about informed search technique, that is best first search and your A-star algorithm. Thank you.